Hello everyone, welcome back to our pre-calculus class. This is our lesson 19, building linear models from the data, which means if some data given, then how can we find out some linear equation from the given data? So data are given, from the data we will try to find out some equation which will represent that data. This is called modeling because model means some algebraic form, some algebraic equation, some algebraic function that will represent the real life situation. That equation or function is called the model. Okay, so we will develop that. Let's look at the agenda. So these are the agenda. First of all, we will try to review the linear functions, like which one is linear, which one is not linear. Scatter diagram from real world data, this two kind of thing. Then finding models for the linear data and pre-calculus scores. This is one example, same type of topic, finding linear model. Then 2 points model, finding a linear practical application of 2 points model, finding a linear equation from the data, modeling relationship with the linear models, and maximum heart rate. So this is like some more application on the linear model. So these are the agenda. We will go step by step. We will look at all these points. First one is how do we identify the linear and non-linear data from our real life situation. So with the progression of time, population of some germs is this. Does they represent? Does it represent the linear or non-linear? Here, the age and the maximum number of heartbeats they are given. So which one represents the linear? Now you can give a try, and then we will see the answer in a while. And the technique here is to find out linear and non-linear. We know that the average rate of change will be same if it is linear. Average rate of change will be same, will be equal. Average rate of change means slope. So if you take any 2 points, let's say 0, 1 and 0 0.9, 0.09 and 0.12, these 2 points, then you can give a try to find out what is the slope, and then you try to find out the slope of other 2 points. First these 2 points, then other 2 points, then other 2 points. If you see the slope is same everywhere, that means the data represents the linear. Another shortcut technique is you look at the difference, common difference in the both sides. If they represent same, then it should be linear. If there is some gap in one side, then you have to look for that gap also. Well, if they represents like similar progression. Okay, so finding the slope is better. So here you can see, if you find the slope, if you, this is the change, 0.12 minus 0.09, change is 0.03, and it is 0.03, 0.04, 0.06. So it is not same. Not same means it is non-linear. Here everything is same, so it is linear. Also another example, another way to understand which one is linear, which one is non-linear is, if you graph a linear function, if you graph some data from the linear progression, then they will represent a straight line. You will get a straight line. And non-linear means now you will get a curve. This is a curve. Okay. Now here the points are not like on a line, but the general relationship, if you look at a general overview, general relationship, which one represents linear here, which one represents non-linear here. And if you look at this, you will notice that this first one, just as a general shape, it looks like a straight line. All the data looks like a straight line. Okay, but this one looks like a curve. You see, this one looks like all the data, if you just take all the data into account, you will see that it looks like this. Then this one, it goes like this, and then it goes like this. Also, you can, just to understand, you can draw a line through the middle, then you will see that or general shape of the data is where. So which one is linear, which one is not linear? I think this is easily you can say that it looks like a straight line. It looks like a straight line, and it looks like a straight line. This is curve. This is curve. This is also curve. So they are not linear. These are not linear, and the tick sign looks like equal linear. So you see, this one, and this one is linear. This one and this one and this one, they are not linear. Okay. And what can be the slope of this figure? What can be the slope? Is it positive, negative, or is it zero? What is the slope of this given figure? What can be the slope of this given figure? Look at this. If you come from left to right, then the line is, this is increasing. You come here, you come here, you come here, from left to right, you see this is increasing. So it is, slope has to be positive. And you come here from left to right, left to right, left to right, left to right, and you see all the head, they are decreasing. So basically it is, slope is negative, decreasing. If it is decreasing, if the linear relationship goes decreasing, then it is negative. And you see all the points here is on one line, on one horizontal line, so which means that the slope has to be 0 here. So this is, slope is greater than 0, less than 0, and equal to 0. Okay, this is the relationship of the slope. Now let's discuss about our big topic for this class, and that is how to find out the model for the linear data. Some data are given. How can you find out the linear relationship? First task is, number one task is to identify if they represent linear or not linear. Now, by looking at the general shape of the data, you can think if they represent linear or non-linear. Okay, you see that all the data somewhat goes like this. So along this box, all the data are along this box. So they actually represent something linear. This data set something linear. So linear means equation of a straight line will come from this data if you try to develop it. Now, one thing is, the points here, they are not on a straight line. They are like at different places, and that is why they are called scattered points. But we'll try to find out a general model for all this data. So suppose if the points are like here, 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 let's say here, so then it is easy. We can easily understand that okay, if I join all these points, then we will get a straight line. But when you go to the real world, real life situation, then all the points you will not get like this. The points will be scattered. Points will be at different places. Okay, points will not be just like nice little line. It will not represent it. So it will represent something like this. It may represent something like this. When you have this kind of scattered points, this is like run, scored, and on base percentage of some national league game. So you see different places, but still they represent some linear progression based on their general shape. We can say that. Now, our question here is, how can we find out linear model? Linear model means, how can we find out a linear equation which will represent this data? So to find out a linear model, linear equation or linear function, first question you should ask is, how can we find normally, without just looking at this, how can we find out a linear equation? So remember, we have point slope form of the equation. If one point and slope is given, then we can find out the equation of line. Or if the y-intercept and slope we have, then we can find out the equation. So basically there is like two very easy way One is if you have one point and slope, then you can actually find out the model. Or if you have um, y-intercept, y-intercept and y-intercept and slope. So from this, actually, you can find out equation of line, equation of straight line. If you know y-intercept is what and slope is what, then you can actually write equation of a straight line. Or if you have one point and the slope, then you can actually find out the equation of straight line. Okay, so these are the two very basic way of finding the equation of straight line. And the formula is, one point and slope formula is y minus y1 equals to m into x minus x1. Okay, and y-intercept and slope, that formula is y equals to mx plus b. So if you have the value of slope and the y-intercept, just put it here. You can just then that will be your answer. Here, if you know a point and the slope, this y1, x1, they are the point coordinate, and the m is the slope. Once you have it, then you can actually find out your answer. Now here, from this data, how can I find out one point and slope? The question is point and slope, or point, slope, y-intercept, etc. How can I find out that? Since there are a lot of points. So the rule here is, from the middle on this straight line, try to estimate any 2 points that will be just at the middle of all these data, which will, like from your estimation, from your eye estimation, try to find out 2 points, any 2 points from this middle of the data. Not, you cannot choose this one. Suppose you cannot choose this one. Suppose this point, you cannot choose this point. They are just like outlier. They are like in the at two different sides of the data lines. Say for example, any 2 points that you think are goes through the middle, you can choose. Now there is a technique actually. How can you understand that which point is in the middle? So imagine a line through the data, and keep the equal number of points on the up and down. Suppose if there is like 1, 2, 3, 4, 5, 6 points down, then there should be 6 points up. Then the line is in the middle. Okay, same points up, same points down. That means then the line is on the middle. Then you can take any 2 points from the line at that point. So this is the technique. Now, if we go for that, these are our 2 points that we think that they goes through the middle. The coordinate of this point 32.7 and 720, and this one is this. So when you have 2 points, then you can actually use the formula that we have shown. Then we can work on that. So first task is choose 2 points. Choose 2 points which will represent all the data. These 2 points. If you draw a straight line through the middle, the straight line will represent all the data. So first choose 2 points, then find the equation between these 2 points. For finding the equation, you need to find out the slope. Slope you can find out just from these 2 points. Do not worry about all other points, because then that's not helpful, because these 2 points are chosen such a way so that the line that connects these 2 points will represent all the data, more or less. Because that is estimation. Okay, we are trying to get a best fit, kind of best fit. The line which fits best for all this data is called the best fit line. So when you have the slope, you put the slope here, and any one point x1 y1, you just put it here, and the formula, just like the formula that we used before. So the same formula we can use, and you get this answer. So this is the line. If you draw through that 2 points, this point and this point, and if you count it 1 2 3 4 5 6 7 etc etc, then you count all the points down up here. Actually, is it 1 2 3 4 5 6 7? 1 2 3 4 5 6 7. So 7 points up, 7 points down, so it is a best fit line. And there is total 7 points up and 7 points down, 7 and 7 points down. That means the line goes through the middle of the data. Now let me show you one very awkward mistake that people sometimes make. So suppose if you draw a line like this, maybe this line will have like equal number of points this side and that side, but this will not be your base fit line, because this is not following the general shape of the data. Your general shape of the data is along this way, so your line has to be along that way. Line cannot be like this. I mean, if you think like, okay sir, you said that equal number of points in the both side of the line, so I can draw this line. No, that will not represent the general trend of the data, shape of the data, trend of the data, general progression of the data. It will not this line will not show if you draw here or here or here. Your line has to follow the data's flow. Okay, kind of that. Now another formula, I said that y equal to mx plus b. So if you increase this line, then you will actually get the y-intercept. So you can, at that time, you can use that y-intercept also from the graph. You can use that y-intercept and you can actually find out the answer that way also. Both ways is correct. There is no but the best way is to use y equals to mx plus y minus y1 equals to m into x minus x1. Why? The reason is, if you connect it, then it actually comes in the middle, and you have to approximate here a lot. Suppose this is 600, this is 650, then your line comes here, and it is what you do not know. Suppose here you have to say, okay, maybe it is 610, maybe it is 615, or maybe it is 605, but that will not be exact unless or until you have a computer to analyze it. So that's why this formula is best, but the other formula also works. I mean, that's not too wrong, but best is this one. Okay, best estimation is this one. So this is how we can actually find out model. So model is which one? Linear model is which one? This one is linear model. This answer is the linear model. Okay, this answer is the linear model. The task is not too hard, by the way. Just choose 2 points through the middle, and then use that 2 points to find out the equation of line. That's the task. Basically, that's the task. And we have more examples here. So some data are given. So actually there are many data. When you have tons and tons of data, then just go for best approximation, estimation. We will accept it. Okay. So say for example here different values are given. We have 2 points, 43 and 66. And so this is another points. So first task is to choose 2 points, which is this. Then the same method, find out the slope. Then take another point and use the equation, use the formula to find out the equation, and this is the line, best fit line. This is called the best fit line. These are actual data from pre-calculus quiz, midterm exam and quiz 1%. These are actual data, actually, not from our last exam, from some of our another semester. These are actual data. So this is like one example where suppose here in our previous example there are many points, but in a practical situation you may see this kind of problem during the, let's say during exams or quizzes, this kind of like less points, not too much, like not 100 200 points, about this kind of points. So for this data, try to find out a model. Then I will show the answer here, solution here. Give it a try to find out a model for this data. So okay, so let's discuss the answer here. First of all, this is like what is going on in this graph, just to give you an overview about that. hours of video games per week. Say some students plays per week 5 hours video game, 10 hours video game. If they plays video game too much, their CGPA falls. Okay, this is the general concept of this given data. So you choose 2 points first of all. Now see, we have chosen these 2 points, but it's not necessary that you have to choose these 2 points, because I will show you why. Say our answer is g equals to 0.156 plus 3.5. So your answer maybe is 3.6, 3.7, and here instead of 0.15 maybe it is 0.14, 0.16, or kind of that. So it can fluctuate a little bit. Okay, but let's say this is 3.5. Can it be 1? It cannot be 1 because there is no data. Line will not go this way. Suppose, so this 3.5, it maximum it can be 4, and minimum it can be 3, because you see all the values are within this band. You see, within this band. So our y-intercept has to be somewhat here, or here, maximum. So within this value, if your answer falls, then we will think like, okay, this is acceptable. But if it goes too much, let's say your answer is here, you wrote here 6, answer came 6, which is unacceptable, because that is way outside the given data. Okay, so this way also you understand it. Another one is, let's say this is minus 0.15 of h, and your answer came plus 0.15 of h. That is also not acceptable, because this is negative slope, line is decreasing, so you should not have increasing slope. Answer should not be positive. Okay, and this is g and h, so this is just variable, no problem with that. It can be y equals to minus 0.15 of x equal to this and this. It can be also like this, but here g means this and h means this. So h is the hours of video games played, so that's why we change the variable here. Another question here is, interpret the slope of part C. That means this slope means what? This slope means what? It means that, see, this is minus 0.15 of this is h, hour. That means if a student plays 1 hour video game, then his or her score will drop, GPA will drop by, minus means drop, decrease, will decrease by 0.15. Okay, so this is written here. Each hour of video games played per week is associated with 0.15 point lower GPA. Okay, so this means that this slope, this part means that hour, this is hour, for 1 hour 0.15 GPA less means minus. Now if we give you a question, if we say that, okay, now find out if someone plays 6 hours video game, then what will be the GPA? So you put 6 hour here, 6 will be here, minus 0.15 into 6, then plus 3.5. Then you do the calculation, you will get the answer 2.6. So this way we can find out that. My point is, here is actually, see, when you build your model, then actually we can understand a lot of other things. We can upgrade our understanding, or we can develop our thoughts from the model. This model tells us some other things that we want to understand. Even not 6 hours, if it is 8 hours, if it is 3 hours, if it is 5 hours, we can just all of a sudden put the value here, put the value here, put the value here, and we can get the answer from this given value. Okay, so we can easily find out the answer this way from here when we get the model. So model actually helps us this way. You can say, sir, why we are doing all this math? Because of prediction, because we want to predict what will happen in the future. Okay, from our real life, actually this is the most important thing, why we build all this model, why we learn all this mathematics. The reason is we want to see the future at present, and mathematics actually helps us to understand the future, because we can predict about this. Okay, if the value is this, what will happen? If the value is that, what will happen? And mathematical equations, they actually gives us that answer. So this is like linear model, y equals to that formula that I said. mx plus b, or slope intercept form. This helps us. This helps us to model a linear relationship. So prediction, where can we use prediction about this thing, and certain different supply demand maths and etc etc. You know, all these things is we can do all these things by this linear modeling. This is a human heartbeats related one application. Say what is the 30-year-old man's maximum heart rate. So maximum heart rate is, example, maximum heart rate is 220 minus age. So you put age here, you put age here, then you will get the answer of this maximum heart rate. Okay, and this model comes from here. Someone said that maximum heart rate function is given by 220 minus age. So suppose 20 years old, someone is 20 years old, then what is his or her maximum heart rate? So you put 20 here, that means 200 beats per minute is in per minute. That's why per minute, 200 beats per minute. Per second is not possible, then they will die. You know. This is we'll discuss it in detail about a little bit. I think we should discuss about all these things in the class also. Sometimes you people give answer which is not practical, you know. So when you write some answer, then think about this: is my answer is realistic? That is very important. Even from the last quiz also, I have seen like some of the answers is not realistic. Even is, first of all, that is wrong. That's one thing, and that is completely unreal answer. That is another thing. Suppose in this math, let's say in this math, let me give you one example. Unrealistic means what? So here we said that, let's say we said that 30-year-old man maximum heart rate is what? So you are supposed to put 30 here and do the calculation. Okay, and then after the calculation, is it possible that your answer is suppose 1560? Is it possible that this answer is not possible? Okay, so one way to see it is this is a typing mistake. Another way is but if we see that frequently one student is writing all this very, you know, different answers, then we think like, okay, the problem is understanding the connecting it with the real world situation or realization. You know, this is not mathematics only, it is actually represents some real world thing. It has to match, you know, with the real world thing. 1560 per heartbeat in a minute is impossible for a human being, you know. This is impossible. You know, the heart will burst if that much heartbeat comes. So you have to think. This is one important thing, by the way. You have to think whatever the answer you write. Is it realistic? Is it realistic? Okay. Is my answer is realistic? That one another example that I said. Let me 1 second. So I said that when some line represents some decreasing slope, if your answer comes for this line, if your answer comes like suppose y equals to 5x plus 3, okay, suppose for this kind of line your answer came y equal to 5x plus 3, is it possible? First of all, it is impossible because it is 5x plus 5x is not possible for this line because it is plus. Positive slope means your line has to be like this. It should go up from the left to right. If you come, it should go up, but the line is going down and it is positive. Positive means this line, but your given line is this one, so it has to be negative. That means somewhere you made a mistake. You understand? This way actually all this thing works. Anyway, so these are the, be careful, okay? That's the thing. So these are the things. Try to solve some of the maths from here, and we will discuss these topics in detail in the class once again. And thank you all. Thank you very much. See you all in the class. Bye bye.